Today, my teammate and I will present you about our advanced big data analytics trading strategy cryptocurrency. Firstly, there is a reason for us to choose this project. Compared to the traditional currency, the cryptocurrency is decentralized, anonymous, backed by blockchain technology, and it has stunning development speed. From this picture, you can see that in the beginning of 2018, both the Bitcoin and Ethereum's market capital have exceeded 100 billions, which is very surprising, and we see great potential in investing in this market. Here is our architecture of our project. We collect price data from Crypto Compare API and Poloniex API, and we apply the CNR model with Python using TensorFlow. And we use SQLite as our data storage, and we do the computation on the Habanero. Lastly, we do with R and Matplotlib to do the presentation. Here is some information about the data we chose. The data range of the training period is from the beginning of 2015 to the 5th October 2017 at 8 a.m. And the validation set is random sample in the training set. And the backtest period is from the 5th October 2017 to the end of 2017. And we chose our data based on traded volume because we want to avoid the influences of our trading action to the market price. And here is some cryptocurrencies we chose. And we want to avoid the survival bias, so we chose the top volumes during 30 days before the test period. And we treat the Bitcoin as a cash asset because some of the cryptocurrencies cannot trade directly with the US dollars. Instead, they trade with Bitcoin. And here is some definitions we will use in our later model, including price vector and portfolio value and rate of return. And we define the transaction cost as 0.5%, and we will make some changes in our later slide. And here is the price answer. We will take it as an input into the model. And here is a structure of our convolutional neural network. And this is the result if we apply model to 5 coins and set initial weights with random numbers. And we can see from this picture that some of the seed don't perform very well, and the best performance value is about 5 times than the beginning value. So we have another thought: what if we apply to 10 coins? And the result is much better, and we can see there is no seed that will lose money in the end. So we want to take a close look at the 10 coins. And here is the portfolio allocation, and we can see that some of the times the fund will put a majority of money to one cryptocurrencies, but most of the time it just make sure that every cryptocurrency has its own weight in each period. And what if we apply to 11 coins, and we can see the result is better, and the best performance seed is 10 times than the initial weight? What if we continue adding the coins to the portfolio? We can see actually the portfolio is better, so we think, why don't we try 20 coins? At the 20 coins, the performance is actually look a little crazy because you see the best performance seed is actually 10,000 times than the initial weight. And most of them is about 3,000 times. So we want to know what happened to the best performance seed. So we take a look to the best performance seed 15. And here is with allocation of the seed 15 in the 20 coins portfolio. We can see from this graph that sometimes actually it's often that the portfolio will put all funds into one cryptocurrencies, and compared to the 10 coins portfolio, the weight allocation is quite different. So we would like to give a second thought to the transaction cost here, because in our previous slide we assume that the transaction cost is 0.25%. However, the transaction cost actually includes three parts. The first is transaction fee, which is charged by the exchange. The second part is the bid-ask spread, and the third part is the market influences caused by the trading action. And for the most volumed cryptocurrencies, there is no problem with the second and third trading cost. However, for the less volumed transaction cryptocurrencies, this is a problem. So we decide to change the transaction cost from 0.25% to 0.5% to cover the spread and the market influences. And here is the result that based on the Bitcoin, we can see that actually the performance actually looks quite normal here. It is about less than 20 times than the initial value. We think this makes the model looks more logical. And here is some comparisons of results of different number of coins. Actually, we believe that there is a pattern exists in these different numbers, and the first thing we believe that is more coins better performance. The second thing is that there is a great influences of initial weight to the final value of the portfolio. Last one is that it seems that the 20 altcoins portfolio performance is a little crazy with a 0.25%. So we increasing the transaction to the cost to the 0.5%. The model is more logical here. And actually our previous models are all valued based on the US dollars. So we decided to transfer it on the USDT, which is a special cryptocurrency that it is about 1:1 to the US dollars. And we can see from this picture and compared to the one before based on the Bitcoin, we can see that there is not too much differences between these two pictures. So here we apply it to the recurrent neural network, and here is some structure of the recurrent neural network, and we apply it because we believe that since the price data is a sequence data, so we believe that maybe it is good to try this model. And here is the 10 coins of the R model. We can see that there is one seed performs very good and one seed performs very bad. So we decide to make a comparison between the R model and the CN model, both with the 10 coins. And here is the result. We can see that the 10 coins with the convolutional network outperforms the recurrent networks slightly, but all in the max drawdown, portfolio value, and Sharpe ratio. So we believe that maybe it is better to use the convolutional network. And there is also one thing we want to stress is that someone may argue that why not just hold a single cryptocurrency all the time. For example, like the Ripple's price rise to 2.27 from 0 to 4 in our backtest period. However, no one is perfect, and no one knows that Ripple would have this great potential. So we checked our Ripple's weight. It is actually around 3% in the 20 coins portfolio. We think that it is very reasonable because our model didn't use the future data. And if you think carefully, that it is almost impossible for a person to hold one cryptocurrency with all the funds and to invest in a long time, so especially in the cryptocurrency market. So we believe that our model is good, and we think that maybe we can apply it with a real business. So thank you.